Hello, good morning to everyone. We are going to see about the cogeneration and waste heat recovery of in the subject of the biochemical and thermochemical combustion of biomass. Next is what is the energy distribution in the power plant or power generation system. First, energy is mainly focusing on the electricity production. In a power station, electricity production about the 20 efficiency of 40%. Another 60% of energy is wasted through the cooling water, through the flue gas to the atmosphere. We are utilizing the wasting energy or energy uh, energy of a 60% of total energy we have focusing to utilizing the energy for a useful purpose, for a heating applications or a process heating, something like that. Next is the heat to power ratio. In thermal power plant, they are using a ratio of a heat to power ratio. What is meant by heat to power ratio? It is a ratio of electrical energy consumption to the thermal energy, or maybe thermal energy to the electrical energy required by the industry. How much amount of electrical energy produced or utilized? Based on that, they use a heat to power ratio. Next is a cogeneration technology. What different types of cogeneration technologies we have? First one is a steam turbine based cogeneration system. Next is the gas turbine based cogeneration system, and combined steam gas turbine based cogeneration system, and reciprocating engine based cogeneration system. In steam turbine based cogeneration system, the main purpose of producing electricity is main purpose. Fuel is burned in the boiler, and the flue gas is passed to, and the flue gas is used for heating water in the boiler. The high pressure, high temperature steam passes through a steam turbine, and the energy is produced. Steam expanding in the steam turbine. Steam turbine is connected to the electrical generator, and it rotates the electrical generator. Electricity is produced in the steam turbine based cogeneration system. Means the energy wasted in the condenser tubes and the flue gases are recovered and used for a process application. Same as the gas turbine based. Here is the component used as a gas turbine, and combined steam turbine based gas turbine based cogeneration system is also available. A reciprocating engine based cogeneration system is utilize the waste energy rejected to the atmosphere in the radiator and flue gases. We recover these heat from the gases, flue gases, and radiator, and use it for the process heating and some industrial applications. When the gas turbine based steam turbine based power plant, the main focus on the increasing the fuel efficiency. The commercial modally producing of electricity, the efficiency of the plant is at about 35% is achieved. We using the cogeneration system, utilizing the waste heat from ejected from the condenser tubes and the flue gases. We recover that heat, we use it for the process heating and some industrial applications. We increasing the plant efficiency about 80 to 80% of plant efficiency. This overall efficiency means we conserving the energy utilization, or we reducing the fuel consumption. Reducing the fuel consumption means fossil fuel utilization is reduced, and the emission to the atmosphere is also reduced. Next is the gas turbine based cogeneration system. In gas turbine, the main heat rejection source is the flue gas heat rejection. In flue gas, around the temperature is 480 degrees Celsius to 540 degrees Celsius. We utilize this flue gas heat to the process heating, or another it is used for a rubber industry, some special kind of applications. It's a gas turbine based power generation system. Normally a gas turbine power plant is having efficiency of around 25 to 35% depending on the type and size of the gas turbine. But we using a heat recovery steam generator or recovery of flue gas waste heat, the plant efficiency is increased by 85 to 90%. By this, we utilizing the more amount of energy and reducing the usage of gaseous fuels, and generating a more economy for a power plant or a nation. This is a block diagram for a steam turbine cogeneration system. It is a block diagram. This is a gas turbine based cogeneration system block diagram. The compressor air input to the compressor, and send it, then air is compressed and its pressure and temperature are raised, then send it to the combustion chamber where the fuel and air mixed and start burning. The high pressure, high temperature gases are then sent to the turbine and expanding in the turbine. It causes a rotary motion. The turbine connected to the generator produces the electricity because of rotary motion. Next, the fuel sent to the supplementary fuel firing. Then a small amount of fuel is added and fired, further increasing the temperature of the flue gas. Then send it to the steam waste heat recovery boiler. Here the heat from the flue gas are required by the one steam cycle. Here the water are heated and converted into the steam by using the flue gas gate. Then steam passes through the process consumer. Process consumers maybe even the rubber, maybe even galvanizing process, some heating purpose. This kind of process, the heat is utilized in the process consumer. Then it is condensed, steam is condensed, then come to the deaerator. Then next pressurized pump using feed pump using to pressurize the water to circulate throughout the cycle. Next, combined steam and gas turbine based cogeneration system. Combined means it combined with the steam turbine cogeneration system with the gas turbine system. The efficiency almost 90% of energy utilization. It is the highest efficiency in this series. Next is the reciprocating based cogeneration system. Reciprocating based means some from power plant they using a reciprocating engine for power generation. Their power utilization. In reciprocating based cogeneration system, normally the reciprocating engine having efficiency 35 to 42%. We increasing the efficiency by utilizing the waste heat rejected in the flue gas and radiator of the engine. Utilize and increase the efficiency of the overall plant. We using the same as the air input to the engine, reciprocating engine. Next is the flue gas engine to the waste heat recovery boiler. Then waste heat recovery boiler, it is a type of heat exchanger. Temperature transfer, heat is transferred to flue gas to the water circuit. Then it water used in the hot water or steam is used in the process consumer. Next is the Rankine cycle. It is a TS diagram of a steam cycle. When the steam and the line horizontal and vertical lines are the horizontal parallel lines are the pressure line, and the vertical lines are the cycle flow of the water change of phase or water state of the water in the Rankine cycle. Next is advantage and disadvantage of the Rankine cycle, reheat and Rankine cycle. Reheat Rankine cycle means after expanding in the single stage of a turbine or a single high pressure turbine, the steam is then sent to the boiler and again it reheated to the high temperature and then expanded to the next lower stage of turbine. By utilizing this, we increase the efficiency of the plant. Next is the cogeneration system, is the topping cycle and bottoming cycle. What is meant by topping cycle? Topping cycle means when the energies are the primary focus of energy production is the electricity, that is the topping cycle. Next, bottoming cycle means the primary energy production, our need of energy is a heat source. It is a bottoming cycle. First one is the primary production is the energy production, power production, the electricity production. Then is the waste heat is replaced for a heat source. Then bottoming cycle, the primary our focus on the heat energy. The wasted heat then will be converted into the converting of again one cycle by converting waste heat into the electricity. This is the waste heat recovery boiler, the combined heat power systems. First is the boiler and used for the feed water used for the process heater. Then in the waste heat used for a steam turbine operation. Next one is the gas turbine based topping system. Maybe on the 500 kilowatt, minimum size of 500 kilowatt to hundreds of megawatts. Gas turbine based topping cycle. Okay, gas turbine operating temperature is higher temperature are used throughout the world as well as effective way simultaneously produce power heat from a single fuel source. It is a gas turbine based power plant is the simplest plant. It can start and stop at a short interval of time, but we can consider as a coal based power plant means steam generation power plant. It may be taken as a 2 to 3 days for a starting and stopping of a power plant. It is the simplest one. We can start quickly. It is an advantage for our industry by using a small size capacity gas turbine power plant. This is a schematic diagram for a gas turbine based power plant. Next one, reciprocating engine topping system. By using a reciprocating engine topping system, the efficiency of the plant is increased about up to 85% of increases